We are solving question number 60 of GATE 2015 Chemical Engineering paper. This question is related to process control and instrumentation. Which one of the following transfer functions upon a unit step change in disturbance at t equal to 0 will show a stable time domain response with a negative initial slope, that is slope at time t equal to 0. So in this question, corresponding to these four different transfer function, we have to find that for which of these following time domain response we will be having a negative initial slope. So the transfer functions, we can write it as output upon input, that is g of s is equal to y of s upon x of s. In this given question, we have been given a unit step change, that is x of s will be 1 upon s. So the response in s domain, we can write it as y of s is equal to g of s into x of s. So this will become g of s upon s. Now we have to find the slope in time domain. So that is which of the following will show a stable time domain response with a negative initial slope. So in order to find the slope, we can write it, the slope at any given time, we can write it as slope at time t. Let's just call it as m. It will be equal to the response in time domain, derivative of the response in time domain, that is dy t upon dt. Now we have to find the value of dy t upon dt and put the value of time t equal to 0, and then find for which of the following transfer function we will be having a negative initial slope, that is for which of the following transfer function m will be less than 0. So if we take the Laplace transform of this derivative, we can write this as dy t upon dt. So this will be, if the derivative of y of t is y of s, no, if the Laplace transform of y of t is y of s, then we can write this as s ys minus y of 0. Now this y of 0, we can find it using the initial value theorem, that is limit s tends to 0 s into ys. So now y of s you can obtain from this equation, and for each of these cases we will be having this y of 0 as is equal to 0. So that is, so this will, the Laplace transform of the derivative will become simply sys. Now since we have to find this term dy upon dt, it will become dy t upon dt is equal to L inverse of s ys. Now ys, we are having it as g of s upon s, so it is, will simply become sys into g of s upon s. So that is the Laplace inverse of the given transfer function. So we found out that the slope of the response of this transfer function at any given time, that is mt, will be the inverse of the transfer function. Now, if you take a look on each of these transfer function, they are having a general form of, let's say, so one is in each of these transfer function, that is 1 upon s plus a. Let's just call it as plus. So over here we are having minus, plus, plus, plus. So let's just call it as plus n times of p s plus b. So for first case, the p will be minus 2, a will be 1, b will be 4. In each of these cases, a will be 1 and b will be 4. And the value of p will be changing from minus 2 or 2 depending on the transfer function. So in order to find the inverse Laplace transform of this, let's just find it. L inverse of g of s is equal to Laplace inverse of 1 upon s plus a plus s plus b. So this will be equal to, first of all, the Laplace inverse of 1 upon s plus a will become e raised to minus of at. So that is, we can write it as e raised to minus at plus p will get common, and 1 upon s plus b will be e raised to minus of bt. So ultimately this is our derivative. Now we have to find the slope, the initial slope, that is at time t equal to 0. That is at t equal to 0. We can find the derivative as e raised to minus of a0 plus p e raised to minus of b into 0. So this will be equal to e raised to 0, that is 1, plus p into 1. So the slope we found out to be 1 plus p. Now for transfer function given by this equation, the slope will become 1 plus p, and the value of p is minus 2, that is 1 minus 2 is equal to minus 1. So over here we are getting a negative initial slope. Now let's just verify for other cases. For b, we are having p equal to 2, and in each of these cases for b, c and d, the value of p is 2. So the slope in each of these cases will be 1 plus 2 is equal to 3. That is for b, c and d, the slope will be 3. That is a positive initial slope. And in the given question, we have to find the transfer function which gives a negative initial slope. That is the first transfer function, that's option A, will be the final answer. So from the given options, we can select this option A as the correct one.